STEM. Educators talk a lot about STEM. What does STEM, what does the acronym STEM mean?
Science, technology, engineering, math.
Science, technology, engineering, and mathematics. NSF is about advancing research and education in STEM. Okay? Broadly construed to also include the social sciences. All right? So my background is as a geologist, a biologist, and a paleontologist. I can't believe it, but it's true, but I can't change it. I've been a faculty member here for 34 years. Okay? I'm a curator of paleontology at the Florida Museum. My research deals with what fossil horses teach us about evolution. I wrote a book about fossil horses. It was published in Cambridge by Cambridge University Press almost 20 years ago. I'm very interested in education and outreach and innovation in graduate education, and that's a result of the fact that I'm getting ahead of myself, but I actually worked at NSF as a rotator for 1 year in the education division in 2009 and 2010. I do a lot of PD, professional development, particularly in broader impacts to teaching junior faculty to do a better job about broader impacts. And I teach a graduate seminar, which we just finished, on broader impacts. And I'm currently a PI, PD, or PI on $13.8 million of NSF-funded projects. Okay? So that's my background, and I guess that's why I was asked to talk today and why I'm standing up here. All right. So what is the funding and structure of the National Science Foundation? The 2011 budget year allocates just over $7 billion for the NSF budget. And if you think about it in terms of how that compares to defense, what it's I don't want to get political, but what it costs to engage in international activities in the Defense Department, this is just a drop in the bucket, okay, in terms of our overall budget. But nevertheless, it's what scientists have to work with to promote STEM. The National Science Foundation is located in, the headquarters is located in Arlington, Virginia, right outside of Washington, and the total NSF organization employs about 2,000 people, of which about 500 are program officers like I was, processing proposals, making decisions about funding, talking with prospective PIs, etc. The National Science Foundation is part of the executive branch of government, so it's part of the President's office. The director of NSF reports to people in the President's office, as well as the National Science Foundation is managed and the oversight is provided by something called the National Science Board, which helps to develop the direction of the National Science Foundation. These are provosts of universities, scientists in high-level positions, influential folks who understand about where science should be going. Every year, on average, NSF receives about 45,000 proposals, of which about 10,000 of those are funded. So you can do the math and the funding rate. It's tough to get a proposal funded at NSF. Okay? When I was at NSF last year, I managed 100 proposals. I was a primary on 100 proposals, and I could fund 12, and I had to decline 88 of them. Okay, so 12%. So somewhere between 12 and 25% is the funding success rate in various programs at NSF. There are various administrative units at NSF, just like we have the president and the financial folks at the university. They have the director of NSF, public relations branch, human resources branch, OG, you don't want to know about all the acronyms, but Office of General Counsel, the Division of Grants Administration, which is like our contracts and grants office. Then the core of NSF that does most of the work in STEM are called the Research and Related Activities Directorates, the R&RA. So biology, computer and information science and engineering, that's those acronyms, engineering, geosciences, math and physical sciences, Office of Polar Programs, and social, behavioral, and economic sciences. Then there's another directorate that I was in called Education and Human Resources, EHR. And then there are divisions that manage large programs that cut across various directorates. And those are called integrative activities, or the Office of International Science and Engineering. So the thing you talked about wanting to work in Brazil, you would talk to the Office of International Science and Engineering. So if you'd never, how many of you have been to the NSF website? Many more than have submitted a proposal. Okay, good. So you know that this is what the home page of NSF looks like. And if you want to know about, what do you work on? Okay. If you wanted to do a search on that, you could print. Or what is your general field? Is it microbiology? Microbiology. Okay. So you could do a search on microbiology, and you could find out what programs are available for microbiology. All right. If you wanted to do a search on graduate students, it would come up. Then it would tell you what programs have keywords with graduate students. Okay. If you're a biologist or you're an engineer, you can actually search within those. You can go into the program areas. I don't have a. Yes, I do. Maybe. No. Oh. Yes. So you could go into the program areas and search on engineering or geology or any of the directorates that you're interested in. Okay? Or you can just do a quick search on graduate students, microbiology, etc. Then there's some. There's sort of the most common places that people search general information about NSF, the merit review process, and various other things. When you actually go to submit a proposal, you do it by an online submission system in what's called Fastlane. There's an entire division within EHR dedicated to helping graduate students advance their education, but also helping them advance research in STEM. NSF understands that the future of science resides in in you guys, okay? And NSF is investing in the future of STEM in the United States through programs that support and promote graduate education. So if you want to specifically go to the place with graduates that has emphasis on graduate students, it's called DGE, Division of Graduate Education. And that's shown for you right here. And if you're interested in particular programs, then what you do is you can click on the Graduate Research Fellowship Program, IGERTS, Science Masters is a new program, and the program solicitations will come up. The solicitations are the documents that describe the different programs. They'll come up and you can read about them. Okay? Any questions? So graduate student-focused activities funded by NSF. We could say that there are some graduate student activities that you can initiate on your own as a graduate student or a young professional. And there are other activities that would be initiated by your major professor or a member of your graduate committee, and those particular programs might have heavy graduate student involvement, training, or focus. So you could participate as a graduate student on your mentor or major professor's project through various programs. And you can surf the NSF website for special opportunities. I just showed you how to do that. So programs that are student-driven at NSF include the Graduate Research Fellowships, the DIGs, although your professor actually has to submit, I believe your professor has to submit the DIG on your behalf. And then when you're finishing up and looking for jobs, there are postdoctoral research fellowships available to graduate students in their later stages of their graduate degree program. And then as I mentioned before, you need to be thinking about how are you going to fund yourself right out of graduate school. Say you get a faculty tenure track job somewhere, and you want to compete in the general program, say in biology or math and physical sciences, in the main research categories. Those are really tough to get because you're competing with seasoned investigators who have done this for a long time and know how to write proposals. Well, NSF realizes that, and there's a special program for that's earmarked for young faculty prior to tenure, and those are called career awards. Okay? Have you all heard about career awards before? No? Good. Okay. So these are, I really think that each of you, if you land an academic position where you're in a tenure track slot, I would encourage you to look at a career award as a way to jumpstart your funding for research and education as a young faculty member. It's good for you. It's also really good in terms of promotion and tenure. Faculty that get a career award, that's really a feather in your cap, so to speak, and it's a good thing for you to try to do. There are other programs that are initiated by professors, but graduate student involvement is heavy. So are any of you graduate students on IGERT? Interesting. Okay, there are there are several IGERTs on this campus. One is called the Water IGERT. One is the Biomath IGERT out of biology and the mathematics departments in College of Arts and Sciences. IGERTs are large interdisciplinary projects that focus on innovative training for graduate students. But they're faculty-driven. They're not, the faculty, it's basically at a faculty level, and then graduate students are recruited into IGERTs once the faculty get the proposal funded, whereas these, initiated by graduate students, are basically you do it yourself, and if you do a dig, then your major professor has to submit it on your behalf. But those are initiated by you, whereas these kind of projects are initiated by faculty, but have heavy student involvement. We've had at least one. We've had a few GK-12s which were getting graduate students into teaching in schools and developing innovative learning modules for middle schoolers, for example, and those are called the GK-12 program. Unfortunately, with recent budget cuts, the GK-12 program was cut, and that was disappointing but true. PIRES, Partnership in International Research and Education. I'm a PI/PD on a PIRE right now where we're taking groups of undergraduate and graduate students to work in Panama and live in Panama for long periods of time, or a semester at a time, and take their classes through video teleconferencing with me back at the University of Florida. PIRES are large grants that integrate different institutions into partnerships with faculty, non-governmental organizations, museums, universities in other countries, and students. And I think these large kinds of integrated global initiative grants are the future at NSF in terms of where funding trends are going. I can talk a little bit about that. I don't have in my crystal ball that in 2013 the budget's going to be X number of dollars, but I can tell you where trends are going in terms of the kinds of things that you should be looking for to fund your research. Have any of you been involved in a research experience for undergraduate program? Okay. Well, so those are mostly for undergraduates, and they're mostly faculty-driven. But the research experience for undergraduate programs need mentors, and graduate students can be involved in mentoring undergraduates just as faculty mentor graduates, postdocs, graduate students, and undergraduates. And that's really good experience for you because NSF is now taking mentoring very seriously as a result of the American Competes Act. Actually, when we submit proposals to NSF that if I have a postdoc in the budget, I'm required to submit a formal postdoctoral mentoring plan. So you need to understand how to mentor, either as a graduate student, certainly as a young faculty member. And a good way of doing that is, okay, you can't mentor other graduate students easily. I mean, you can if you're a senior student, but it's one thing that you could clearly do, you could put on your resume, and it would give you great experiences to mentor undergraduates in programs like REUs. And then finally, there are most research awards coming out of the RNRAs, the Research and Related Activity Directorates, have money for graduate students. That's the way I support many of my graduate students through standard grants coming out of the Geoscience Division. All right. So what's going to happen when your proposal is submitted to NSF? It's going to be all proposals are sent out for review, and those reviewers will recommend either by ad hoc fashion to the program officer or via a panel, what they think about your proposal and how it should be ranked. It takes 6 months, so if you want to go to Brazil this summer, you're probably out of luck. Okay, you'll have to think about next year. You'll hear much sooner if you don't submit the proposal and it has all the compliance details like the size of the font and all the other silly things that people like myself, when I used to be on the outside, hated, but when I was on the inside, I understood. If your proposal is not in compliance when you submit it to Fastlane, and let's say you submit it on the deadline date, the program officer looks at it and it's not in compliance. It's too long, or the font size, you have to use a magnifying glass to read it. It'll be returned without review. And nobody wants an RWR because you then have to wait for 6 months or a year for the next deadline cycle. You don't want that to happen. Your proposal has to be in compliance with all the regulations about font size, margins, etc. Okay? Every one of the 45,000 proposals that's submitted to NSF is judged based on 2 criteria. One is the intellectual merit, and the other is broader impacts. So intellectual merit is, what do you want to do? What sort of advances do you want to make? And why is it important to you or to your profession? Broader impacts is basically ask the questions, why should society care about what you do? If you can't answer the second question easily, you're not alone, because most senior people like me were raised in a culture of the only thing that you do at NSF is focused on intellectual merit. I'm going to do really great science, and I'm going to communicate it to my peers in my narrow discipline. And that was good enough, but it's not good enough anymore. Okay, so now there's this additional requirement of what's called broader impacts about who in society or outside of your discipline should care about what you do, and why is it important. Okay, how many of you are comfortable with the concept of broader impacts? Great. That's much better than my generation, okay? But not everybody does feel comfortable with broader impacts. Most people intuitively, most scientists intuitively understand how they're going to advance research and how it's going to be important to their disciplinary community, but most scientists don't understand how to communicate what they do and make it relevant to society through broader impact activities. And in fact, NSF understands that broader impacts are hard to do, and they actually say in a white paper that was issued in 2007, many proposers have difficulty undertaking how to frame broader impacts of the activities that they undertake. And why is it so difficult? Why is it so difficult for people of my generation to do broader impacts? It's because prior to 2002, there was no expectation of broader impacts in NSF proposals, and there's no training. Have you ever been trained in broader impacts? You have. How have you been trained in broader impacts?
Every class, like it's kind of a subtext.
Cool.
I'm interested in anthropology.
You're in anthropology.
So, studying leadership, get that broader impact.
Great. Okay. How many of the rest of you have taken coursework or training in broader impacts? Okay. How many of you taken coursework in your own discipline? Everybody's going to raise their hand, right? Right? If you don't raise your hand, then what are you doing? So NSF expects you to do both of these, but you're getting no training in one of the important parts of it. So how are you going to understand how to do it if you haven't had it in a class? Okay? You got to take training. You have to understand, okay? The way to understand about how to do broader impacts is fairly simple in the broad details, and that is there's a document that was published by NSF in 2007 called Broader Impact Review Criteria, or Representative Activity. And NSF has identified 5 ways, 5 general areas in which you can do broader impacts. Okay? And one is advanced discovery and understanding while promoting teaching, training, and learning. The other is broadening participation of underrepresented groups. The third is an enhanced infrastructure for research and education. The fourth is broad dissemination to enhance scientific and technological understanding. And fifth is why why does what you do benefit society? If you can put in your broader impact plan, in your proposal, some aspects of 1 through 5, not all of them necessarily, then you will have done a comprehensive broader impact strategy to do what you need to do in terms of writing a better proposal. 10 years ago, what we used to do is, as PIs writing proposals, that we said that I'm going to talk about my research discoveries in my classes and to my graduate students during lab meetings. That's not good enough anymore. You have to reach outside of the so-called ivory tower to do broader impacts. Okay? So the first is advancing discovery and understanding while promoting teaching, training, and learning. You can integrate research into your teaching. I said, yeah, we all do that now. That's ho-hum. It's expected, but it's not innovative. Include and mentor students in your research. Yeah, of course. Recruit and train teachers. Now that's stepping out of your comfort zone, perhaps. If you're doing GK-12, if you had been doing GK-12, that's okay. It's going to be more difficult now. Develop. How many of you have taken classes in how to teach in pedagogy? Okay, 5. How many of you hope to teach in your first academic job? Well, maybe you don't want to teach, you want to do research, but how many of you will teach if you get an academic job? So then how are you going to learn how to teach? By teaching. Okay, that's the way I did, but educators know that there's theory and principles and best practices of teaching that you can learn that make you a better teacher. And maybe through what you're doing, you can learn how to do innovative pedagogy, learn how to teach, do a better job of teaching. And then you should promote other colleagues to do the same in this first category. Broaden representation of underrepresented groups. You need to figure out who, in your study, is there an audience that you'd like to reach out to engage them in what you do? It might be urban underserved. If you're working in rural communities, it might be rural underserved. It might be cultural groups. Think about what makes sense. Okay, and then say, for my broader impact activity, I'm going to disseminate or somehow engage that target audience and promote my research and educational collaborations with them. Maybe that deals with working with an inner city middle school teacher, okay, that has a large proportion of her students from underrepresented groups, okay? Another thing you can do as faculty is if you're at a large research university, you can help smaller non-PhD granting institutions and partner with them to make what they're doing stronger, and then you're drawing them in, you're broadening representation in your project. When you have conferences and workshops and other activities, make diversity, recruitment of diverse participants a proactive strategy in terms of who's going to be at those meetings. And mentor young as senior faculty, make a commitment to mentoring young faculty, and particularly diverse young faculty. Okay? Now, a lot of this doesn't pertain to you as young scientists. Some of it does, and some of it's sort of later stages, but you should be thinking about this framework for your entire career. And as things make sense, and you have innovative opportunities that could broaden participation, you should think about including those in your broader impact plan. Enhancing infrastructure for research and education. NSF likes partnerships, both in the United States and internationally. The partnership that I have with folks in Panama through a PIRE is an example of that. If you're involved in using research instrumentation and you're improving upon it, that's a good thing. And do that and then communicate that to, don't just design a new instrument and use it yourself. Design a new instrument, use it yourself, and then promote it to other people so they can use it to advance their technology. NSF is all about cyber infrastructure. Anything that you do that upgrades or innovates in computers can be promoted to the general public and can be viewed at, not the general public, but the larger community, larger community, and you can tout that, you can use that as part of your broader impact plan. Develop activities that engage large number of science students through lectures, outreach activities, etc. Broad dissemination to advance scientific and technological understanding. You can partner with museums. I'm a museum scientist, and if you have an idea for an exhibit, a kiosk that you might want to have in your department, or in a middle school, or in a government agency, think about doing those sorts of things. You can do cyber exhibits. How many of you have a research website? Okay, well, that's developing a research website that communicates the results of your research discoveries is a way of disseminating what you do to whoever wants to look at your website. Okay? How many of you have given talks to civic organizations? Rotary, okay, one hand, two hands. I talk a lot to fossil clubs. So around the state, there are groups of fossil clubs that meet once a month, and they like speakers to come in. So I go and give talks to fossil clubs, and so do my students. So if you're if you do ornithology or I don't know, whatever you work on, and if there are interest groups, if you're an astronomer, you know, there's the Alachua County Astronomy Club. Think about giving talks to those sort of organizations. It's good for outreach, but it's also very, very rewarding because you're going to talk to people who have chosen, rather than watch TV or football on a Saturday night, they've chosen to come and hear you talk, and that's it's much more rewarding than teaching hordes of undergraduates who are playing or who are texting their friends and stuff. Okay? Publish in diverse media. Don't just publish in your scientific journals. Once in a while, step out of your comfort zone and publish in broader Smithsonian, for example, or Popular Science or Popular Mechanics, Sky and Telescope if you're an astronomer. Write an article for the general public. It'll help you to be a better communicator. It'll also disseminate your work. And also, you can do documentaries if you don't want to write. A big new initiative in communicating research from scientists to the public is through working on mini documentaries and YouTube. How many of you have done a YouTube on what you do? Have you ever made a YouTube? Okay, somebody in the back there, about your research discoveries. Lots of folks are doing it, and it's an easy and good way for you to communicate what you do to the public. Benefits to society. Demonstrate linkages between what you discover and why it's important. Okay? Partner, if it's appropriate, partner with government agencies and private sector to integrate research into activities that would benefit those entities. Okay? Present research and education results in formats understandable to non-scientists, fossil clubs, civic Rotary Club, etc. A lot of you haven't done that. Mostly professors give talks to Rotary Club. All my graduate students give talks to fossil clubs. That's something that I encourage them to do and find money for their travel to do so. But as you progress in your professional development, you'll have opportunities. Somebody will say, would you give a talk to a Rotary Club about what you do? And then you have to figure out about how you're going to communicate what you do to a group of folks of a diverse background who may not really care about whether you've made a new such and such, okay? And then if requested, provide information for policy formulation for federal, state, or local agencies. If you do conservation, climate change research, things like that, you may be called upon to provide your expertise in certain settings in federal, state, or local agencies. So the bottom line recommendations about broader impacts. Here I am giving a talk to a fossil club at the top, and at the bottom I developed an exhibit on the largest shark that ever lived, and here's a mom and her daughter enjoying the megalodon exhibit. Broader impact activity, don't fake it. Broader impact activity should be integral to the project, your project from the beginning. Integrated in, don't think about it at the last minute when you're just about to finish up your proposal, the day before you submit your proposal, and in the, most NSF proposals are 15 pages long and no more, and frequently the situation occurs where the first 14 pages are spent on intellectual merit, and the 15th page is completely separate and is written for the broader impacts. That doesn't normally do well in terms of competition. You can't do everything of each of those categories of all 5 things that I just talked to you about. You can't do them all. Pick out several of them that really make sense to your project, that you're really passionate about and pursue those. And NSF will like that better than you wanting to do sort of a little bit of everything and it sort of not be meaningful. And then enjoy these activities. In my opinion, they'll pay back much more than you can realize. All right, so why should we care about broader impacts? Well, because NSF and Congress care. I'll skip over. I didn't talk about Golden Fleece Awards. And also philosophically about, I asked my students in my broader impact class, why do you want to be a scientist? The first day of class, I asked them, why do you want to be a scientist? And if you haven't asked yourself that question, you might want to ask yourself that question and reflect on it. I mean, some of us just sort of, well, you get accepted to graduate school, you're in this narrow focused project that your advisor has money to fund for you, and you're doing it because there's that opportunity. But have you ever sat back and said, you know, when I finish my career after 30 or 40 years, what kind of impact do I want to have made on society? I think you ought to think about that. Because for several reasons. One is, philosophically, how do you want to contribute as an individual to science, but also how do you want to promote science to the general public? Doing broader impacts might allow you to ask new research questions, and it will also help you with the current. There's basically an anti-scientific movement in terms of U.S. culture. People don't believe about the public understanding of evolution has not changed in 25 years in terms of the Gallup polls. About half of the U.S. citizens, about half the people polled with a Gallup poll believe in evolution, and the other half don't now. And that's the same as the exact same questions were asked by the Gallup poll in 1982 or 1983. There's been no movement in acceptance of evolution. Think about climate change and sort of the believers versus the naysayers. So if you could have a part in advocating, in not advocating, but in communicating your research discoveries to broader society at large, I would argue that it makes you a better scientist. Okay? Take-home messages for graduate students: think outside the box about funding. Don't just look for the graduate research fellowship. There are other ways. Talk to your major professor. If you see an interesting program that you learned about today, or if you search the website, talk about it to them, and if they need to get involved, get them involved in doing it, help them write it. There are no secrets about how to succeed at NSF. It's tough. It's just a lot of hard work. It's mostly an objective process. And finally, don't be, a lot of you raised your hands that you're not afraid of broader impacts, but it's interesting. This talk was modified from a professional development talk that I normally give to junior faculty, and fewer people in the audience would raise their hand when I say, how many of you are comfortable with broader impacts? I really believe the culture is going to change as it's going to change with you, the graduate students, the next generation, who are being brought into this way of thinking about how you do research and science through intellectual merit and broader impacts, and it'll no longer be an issue to you guys because you were, so to speak, brought up with it, rather than it having been foisted upon you as a more senior scientist like myself. So, I have time. I mean, we have about a half an hour, and this is supposed to be a breakout group with discussion. So let's see. The first question that I remember is, what's the future of funding for NSF? That was your question, right? So, next budget year, there's a 1% cut. So instead of being, I forget exactly what it was, but it's 1% of about $7 billion. Okay, so that's not a humongous cut relative to other federal agencies. So NSF has fared relatively well. Okay, but what's going to happen? That's the 12 budget. They're in 11. 12 starts on October 1st. The federal budget cycle is October 1st to September 30th each year. So on October 1st of 2011, the 2012 budget will start. And that represents a 1% cut over 2011. What's going to happen in 2013, 14, 15? Hard to say. If I had to predict, I don't see, based on the current climate about funding for scientific research, as having major gains relative to the current budget. Okay? But there are niche opportunities at NSF that most folks don't understand, and I see the days of what are called single investigator awards, where your major professor, or what I've done for 30 years, going and writing a proposal for a couple $100,000 and maybe having a collaborator and going in to focus on answering a particularly interesting question within my discipline, I see those days as not getting any better. Where I see the growth at NSF as in these large integrated activities that integrate research, international experiences, mentoring, training graduate students, undergraduates, these larger proposals that are in the millions of dollars range are the future at NSF, in my opinion, because NSF understands that these large collaborative proposals tend to have more benefit than what are called the traditional single investigator award. You doing a DIG, a doctoral dissertation improvement grant, is a single investigator award. You've received some funds to work on your own project, and basically that's it. Okay? When you get your job as a professor or as a researcher in wherever, those are still going to be around, but I don't see growth, increased opportunities in single investigator awards, and you need to think about partnering with larger consortia to work on larger awards. They're all really tough. The funding rate in single investigator awards has declined. When I first started writing grants 35 years ago, the success rate at NSF was about 33. About one out of 3 proposals were funded, and now it's anywhere from 12 to 25% depending upon the program. Remember, 45,000 proposals are submitted, 10,000 on average are funded. Okay, other questions? Yes?
In terms of broader dissemination, when you're working with live human subjects, it becomes a little bit more complicated.
Mm-hmm.
I work with a media site, an NGO overseas, where we do video testimonials, and we're thinking about all this thing online and what that process looks like. I know you specialize obviously in radio,
Mm-hmm.
but you speak to any proposals you've seen that are in dissemination for graphs and we do this live subjects.
Well, if you are acquiring information from them, you have to get IRB approval. Anytime anyone works with human subjects at the university, you have to seek and obtain Institutional Review Board IRB approval. So you might need to see if they are interested in looking at what you're doing. If you're interviewing them or collecting demographics, if you're getting information from the human subjects, then you have to go through IRB.
We have IRB approval. I'm just kind of concerned with later on applying for next year the NSF graduate research fellowship. Talking about that, I can say I have approval.
Yes. It would help. What will happen is if you don't have approval, it probably would not nix your proposal. What would happen, though, is you'd have to just get approval. Your proposal will be funded contingent upon IRB updated approval. So it's better you get it before, because then it shows the program officer you've done your homework, and this is not sort of a last-minute thing. Okay? Yes?
The course, the broader impact course,
Yeah.
what is the section number, not section number, but the actual letter code?
It was. That's an interesting question. We actually want to get it ultimately. We want to institutionalize the Broader Impact Graduate Seminar at the university, and we'd like to get there's an interdisciplinary prefix, but right now the prefix is GLY for geology and ZOO for zoology, and it's 6927. It's a special. It's ZO 6927, and it's GO 6932. Broader Impacts of Science on Society. It'll be taught next spring. We just finished teaching it. Okay? I'm teaching a course in the fall on how to design natural history exhibits, a graduate seminar. If anyone's interested, you can get in touch with me. Okay? But I think that's the answer to your question.
And so with this course, courses offered distantly at all? I'm mainly working at a research and education center in the state.
Say that again. You're working at a research and education center.
In the state in Florida.
And could this be offered by, like, Polycom, you mean?
Right.
The answer is yes. We didn't do it this semester because there were no students who were registered outside of UF, but I have a cohort of students that are going to Panama next year, and some of them are going to take my class. So they will register for the Broader Impacts Graduate Seminar, and we'll do it by video teleconferencing. And that's now becoming a routine. I do that, and so the answer is yes. If you're interested, you'd need to get in touch with me, so I know that some of my students would need to, we need to make arrangements for that. Yes?
As far as like speaking to the public and the clubs and things like that, how do you start doing that? Do you wait until you're invited and asked to speak, or do you contact people and say they're interested in speaking? You haven't done it before?
Yeah.
How do you get started?
Well, there are two questions. How do you get started getting a place to speak? And the second is, how do you actually present a talk to the general public? Those are two different questions. If you're, what's your background? What's fisheries? Okay, so what kind of clubs might be anglers? What kind of clubs? They're definitely fishing clubs. And do you have a message you'd like to communicate to fisher people? You don't have to just say yes or no. You don't have to tell me what it is, but so then you have, if you think what you're doing is of interest to angler clubs, then you need to contact them. I can guarantee you that every club that I know of is always hurting for speakers. In terms of what I do, I have friends in astronomy clubs, and I do fossils. So I know, but bird watchers, various other butterfly clubs. I mean, if you work on organisms that have special interest to sort of niche clubs, you should go ahead and if you want to try, get in contact with them. And the other thing is, if you're writing a broader impact plan for a proposal and you've done that, then you can, so to speak, claim that as part of your broader impact strategy. So that's the first question, is how do you make contact? Be proactive. The second question is, how do you learn how to talk to the public? And that's not trivial. Some people can communicate to the public, but we have a vocabulary as scientists that is unique to our own discipline. And the problem with talking to the general public is you have to completely forget that vocabulary and explain what you do in a different vocabulary. And getting from this, I don't say it's better, it's different. From your old specialized vocabulary, you have to figure out how to explain what you do without your specialized vocabulary, and that's tough. So I have my students, before my students give a talk to a fossil club, I have them do a practice session with all the other students and myself, and I write down any of the jargon that they use, and I say, you can't use that, you can't use that, you can't use that. So basically you practice with your friends, practice with people outside, your friends outside of your discipline, and see if what you're doing makes sense to them. Practice, and just sort of test out what you're doing. And once you've done it a couple of times, you understand how to do it, and then it's okay. Then you'll know how to do that. That's really important. Anything else? Yes?
This is specific in just thinking that I don't have too much, at least 1 year, maybe a little bit more left in my program, and so I'm kind of late beginning to apply, I feel like, for funding. But my question is, first question is, do you think you can still apply with a year left in the graduate program? And if so, if you do get funding, does it depend on the grant or the awards, what you have to do at the end? Do you submit a report back to NSF on your results and what you've done?
Yeah, there are two questions. Yeah, two questions. One is it too late for you to apply? What program would you be interested in applying to?
Probably one of the student ones, or maybe a dig.
Yeah, a dig probably is okay as long as you can demonstrate that you really need, that you're at a stage in your career where that will help. There are some eligibility requirements for graduate research fellowships. You'd have to read the language of the solicitation. I don't know the specifics there, so that's the answer. The answer to your first question is perhaps, but you'll have to check the programs. The answer to your second question is all NSF reports, every one of the 10,000 that are funded must have a report written about it. Yes? Okay. Anything else? Yes, in the back.
How specific or technical it has to be about broader impacts? Because I'm from Honduras and I grew up doing a lot of outreach and communicating my research. So I do it all the time, and to me it's something really natural. So how
You don't have, most people haven't taken a class, and that's not a problem. Just if you've already done it, and you can describe your experience, and then communicate your passion for what you want to do as terms of the broader impact. It's fine that you have never taken a class. It's also fine that many of us teach at universities have never taken a class on how to teach. It just is what it is. It's on-the-job training. That's fine. Don't worry about it. Very few graduate students nationally have formal training in broader impacts. That will change, I would say, in the next several years, but very few have.
But it's okay to use like more technical, like how are you gonna help the authorities to make decisions, or like, you know, make it more structured?
Yeah.
Or because I think the way I approach it is more too disorganized. So that's like,
Follow the outline of the 5 points that I showed you. That's what I do now when I write a broader impact statement, and talk about what you want to do within those five different kinds of broader impact activities. And that is a good way of starting. Okay? Talk about what you've done. Talk about what you want to do as it relates to your research discoveries and how you're going to do it. And you should be fine. You're welcome. Yes?
Does early submission increase your likelihood of receiving funding?
No, not at all. What we do as program officers is we wait until the deadline, and then a huge batch of proposals are sent our way and assigned to us. So early submission does not affect, that's a complicated question, but on the face of it, early submission does not affect funding. There's another question about when to submit, when to time the market, so to speak, in terms of when NSF is out of money. If you're submitting in like July, like June, during the summer, most of the money for that year has been obligated to other proposals. So they might be out of money for a particular program you're applying to. But that's, I would say, not. NSF does a pretty good job at managing that. That's sort of more of an internal nuance. I would say, if you submit early, submit late, right on the deadline, doesn't matter. If you submit early or on the deadline, by the deadline, you're fine. You can't submit late; they won't allow it. Fastlane will reject it. And rarely do program officers allow extensions, because a lot of people, we basically take a hard line. You got to get it done on the deadline, by the deadline. Okay. All right. So if there are no more questions, that concludes this breakout session. And thanks.